Exporting videos from processing is quite easy. I'll show you here 3 methods. First method, use saveFrame with PNG and record all 360 frames and then combine them with the Movie Maker in processing into an MOV uncompressed file. And this is the video. Second method, use the export library by Bitrates, check the examples on his GitHub and use them for your own sketches. It's simple and you directly export MP4 video files. Here is the video. Third method, use a screen capture software. I use here Streamlabs OBS because it is free. Specify the output size, select the sketch window, change the bitrate and record. Here is the video again. Alright, we just recorded 3 videos. Perfect. Welcome to The Dot is Black. I'm David. This was perhaps the shortest tutorial on this channel, 3 in 1. But don't worry, I will talk about this in the next video. I will emphasize on each method, its strengths and weaknesses, and also will tell you, and also compare them actually, and also tell you which one is suitable for which case. But what is then this video about? Well, if you have videos, if you export videos with processing, you also want to use them somehow. And in order to do that, we need to cover certain knowledge. What are videos? Because unlike images, where you have maybe just like a handful of video formats or image formats, whether it's raster or vector images like PNGs and PDFs, videos are much more complex. And in the beginning, if you don't work with videos, you have nothing to do with that, except that you have your phone and you're filming, it can be quite frustrating, especially if you have something on your screen and then you export it, you upload it somewhere, maybe on Twitter or Instagram or YouTube, and suddenly you can see the quality drops of the image. It doesn't look the same as in your computer. And I would like to show you why that's the case and how you can actually improve it. Let me show you a few examples of problems in my videos. So this video, you know, it's on my channel. You can see this. It's an abstract art with gradients, and you can already see it. There are lots of problems, especially here in the areas where the gradients are kind of vanishing into white or become blue. There is a lot of banding and macro blocking, that you call this. And it's very difficult to actually get rid of it. Next video is it's a generative portrait, and it's actually quite a nice piece of work. I like it very much. And there are lots of particles are moving, but as you can see, they all kind of mashed together. There's nothing is crisp, nothing is detailed. Everything is kind of mashing together. Everything is pixelated, and this is called macro blocking. And it's very hard to work with that. There is a reason for that, why this is happening. When you look at this a bit in the front, so you see there is no banding, there are no gradients kind of appearing, or no macro blocking because the image is not moving actually. So there are 2 differences. Likewise, this thing also happens when you have a very simple image or very simple graphic, like in this case, this tutorial, the introduction to it. You can see those are just very basic shapes, but nothing is very crisp here. Everything is very blurred or jagged somehow. So it's macro blocking. And once it reaches a certain scale, even here, even this is quite big, it's still not very crisp. Now it's perfect. So that's kind of actually quite interesting. And I'd like to actually talk about this in this video. I want to make it for you clearer why this is the case. So let's start. What is this video about? Resolution, FPS, pixel aspect ratios, containers, codecs, video bitrate, perhaps one of the most important things in video editing. Requirements for export, lossy versus lossless, and my personal recommendations. How to export videos, what you should pay attention to. Resolution. There are certain aspect ratios in terms of videos, 4:3, 16:9, 2.35:1, which is for cinemas. And the most common one is these days 16:9, because our gadgets like mobile phones, tablets, laptops, the screens, TVs, everything is more or less built for 16:9 ratio. And that's also when you work with, when you design your sketches or you work on your sketches for videos, you should also use this ratio because that's the most common one. 4:3 is not really useful. Likewise, 1:1 is also not really video ratio. That's usually just for social media. You can do this, you can always crop it, but if you work a proper video, it's 16:9. Also, you can of course rotate it 9:16, like for example Instagram stories or Facebook stories. There are lots of possibilities because again, when people watch their phones, they usually watch it in the portrait format. The aspect ratios, like 16:9, there are of course different kinds of resolutions, and the most common these days, they're of course smaller ones. We have the high definition 720 pixel or 1280 by 720. Then we have the full high definition 1080p, and then we have also ultra high definition or 4K, which is 3840 by 2160. And all those three ratios, those are the most common, and you should always choose one of those. I don't believe that 4K is necessary because it's just too large. You need a very powerful computer, and most of it is just simply not necessary. Most of the people don't have yet a 4K display, and even if someone has it, it's not necessary. It's just a waste of time. The best and most versatile resolution is 1080p, so full HD. So if you work with processing and you design your videos, or you make videos, you make codes for videos, use this resolution 1920 by 1080 for the size window. You can also alternatively start with 720p, so 1280 by 720, the size of the window, and then you just scale it up, your processing sketch, inside the processing sketch, not the video itself later. Very important, do not upscale your videos, because what happens is you might have a very small sketch because we maybe have screens and we're used to the small format that we work with. But when you upscale your video in a post edit, maybe when you upload it somewhere, it already upscales as well automatically, or maybe you do it in a software, editing software, video editing software. What happens is when you upscale, that the edges or the image itself, the picture quality of the video becomes very blurred, and you can hardly work with that, and it's actually usually quite bad. So do not upscale your videos. Work always in the proper resolution and proper aspect ratio of the video. And additionally, so you see here, many of us also of course work with processing, and most of the work that we do is usually graphics or still images. There is lots of animations, but in general, I think, at least in my case, I work a lot with graphics. And a graphic or drawing is not a video, because drawings are much, much larger, actually, really, really big. And a screen is small. It is limited by pixel sizes. So when you see here this drawing, it's quite nice. You have a lot of details there, very thin lines. And the lines, the density of these lines adds life to this drawing. However, when you make a video, everything of this completely disappears. And actually, even worse, it's going to make a lot of problems. So for example, this was a tutorial. I think some of you will know the introduction. It's exactly the same code. It's just further developed for the drawing before. But I also try to maybe share this drawing with other people, this code. But it was not a video, so I tried to adapt the drawing to become a video, and I used in the beginning very thick lines that become smaller. And what happens is, because it was a drawing and not a video, the quality instantly decreases. Let's have a look. So you see here, the lines are very nice, sharp, everything is perfect, but as soon as there are many lines, like 3000 lines by the end, the quality of the image, of the video image, is just gone. You can't see any lines anymore. And that has to do with the reason for that is actually that this was a drawing and not a video. But nevertheless, I did this. I knew it's going to happen, but I wanted to actually do this tutorial for the drawing, not so much for the video. So when I talk about videos and drawings, obviously you know already that when we work with drawings, we have a lot of nice, beautiful lines, very thin, 1 pixel lines, for example, sometimes less than 1 pixel, because it adds life to the drawings. And the more complexity we have, the more we overlay lines, the better it looks like. We can interact with it rather. However, for a video, 1 pixel lines are quite bad actually, especially if there are many, many lines overlapping next to each other, because once you start to downscale your image or your video, the lines become even thinner. They become all the way down, perhaps even like 25% of the original one, which is like 0.25 pixel wide only. And if you then have too many lines next to each other, the video export will be possible on your computer, but as soon as you upload somewhere, it will create problems. You will not get this clarity of it that you see on your display. So every time when you try to downscale, before you downscale or maybe upscale, please work rather with proper line weights. So the stroke weight should be at least 2 to 4 pixel wide, I think, in my personal experience, if you want to have a good drawing. Then you avoid a lot of mistakes, or a lot of errors, actually, not a mistake. It's just only you need to understand that if you have too thin lines and too many lines next to each other, it will cause problems. As even this one pixel on a white surface, and it's moving very quickly, it will also cause problems. Now, to achieve a high quality video, write your code specifically for video output. Use always the correct resolution and ratio, 16:9 best, it's usually the best. Do not upscale your videos and do not downscale your videos. A drawing is not a video, of course, so keep in mind that. FPS. FPS means frames per second, and pretty sure most of you are aware of this. And there are basically two standard sizes for us at least, it's 30 frames per second or 60 frames per second. 30 frames per second means that there are 30 images compressed into 1 second, and we watch them as one motion. So that's basically a video. Whereas 60 frames per second means there are 60 images or 60 frames within 1 second. That means there is the double amount of information, and that's actually quite good, because the more information you have, the better your video will look like, or the more information you have, the better the motion is. So if you have, for example, some sketch where you have motion in it and you want to export it, use 60 frames per second. 30 frames per second is good for drawings, like drawing still images, or maybe something is a bit moving. That's good. But for motion, especially quick motion, 60 frames per second always. And if you go, like for example, in editing softwares, in this case Adobe Premiere here, you can see there are many other frame rate numbers. You can see already like 5, 10, 12, 15, 18 is like Super 8. Then you have some strange numbers like 23.976, 29.97. Then you have also 59.94. Those are very strange frame rates. Choose always a very clear number, 30 or 60. 24 is also a standard. It's a standard frame rate, but that's generally for movies. For streaming, for example, 24 gives like a bit like a distance. It's a bit more artistic perhaps, whereas 30 and 60 frames, they are more for live broadcasting, like news, for example. It looks more real, authentic. So you can also use 24 for particular drawings. I use also 24, but in general 30 or 60. So use always high frame rates. The higher the frame rate, the better the motion, always. Higher frame rate increases the quality of the video. We will talk about this in the bitrates. You will understand better why higher frame rates are better actually for us. Avoid frame rates like 23.976 or 29.97 or 59.94. That's generally not good for motion graphics. It's just impossible to work with that, to be honest. And even when you export it for example, in Premiere, it will reduce the quality of your work. So keep it in mind. Work with sketches, or when you make a sketch, specifically choose a frame rate of 30 or 60 for motion in this case, and adapt all counters and variables accordingly. So I have here, for example, this sketch that we saw also in the beginning, and it's a very simple thing. It's just a rotating square. So if I want to export it, and I know already it's 30 frames per second, so I choose my counter for the rotation at 1 and I give it like always 1 degree only. That means 360 degrees, I will have to export 360 frames, and it will take 6 seconds to rotate for the whole thing. But you see already in this video, it's a little bit too not very smooth. So I would have to increase this to 60 frames per second. And to do that, of course, I will just divide it by half, my value to rotate. So I make it much smoother, slower, and the motion looks much better. And if perhaps this is even still too fast, because the larger the objects, then the edges don't look very smooth, I can even decrease the motion, and I still export it at 60 frames per second. and then it looks much smoother. So when you work with frame rates per second, keep in mind, use also your variables and counters accordingly. Pixel aspect ratio. That's also something, perhaps not the most important thing, but it's good to know it, because when you work, usually when you work with processing or you work with the computer and everything is digital, you will have no problems with that. You only will have a problem once you get into post-editing with a video editing software, and for example use some sequence presets like in Adobe Premiere, and then suddenly you see this pixel aspect ratio, which it says here anamorphic 1.33. It's very strange. Likewise, like you have a very strange frame rate, so you have to actually change those settings. What is this pixel aspect ratio when it says 1.333? So generally our pixel ratio on our displays when we work with processing is 1:1. So every pixel is equal, everything that we see is equally 1:1. However, in certain videos, especially like for movies, there is a different aspect ratio. It's 1:1.333. That means that these images that you produce, if you don't pay attention to, they will be transformed. They will be basically stretched and some pixels will be removed. When we have here 8x8 pixels, then if we use this pixel aspect ratio, the computer will transform it or translate the video image into 6x8 pixels only. So it will become stretched. That's the problem happens then when you have some geometric images, for example, geometric shapes. Then before it was probably a nice circle. Once you use a wrong ratio, the objects inside your video become stretched suddenly, and that can be a problem. So when you use this, keep in mind there is a pixel aspect ratio, and when you edit, post-edit in any software, editing software, check always the pixel aspect ratio. It should be always 1:1, because every streaming platform also uses 1:1. We watch things on our digital displays. And you can see also here with the display, with the size, the resolution, when we had before 1920 by 1080, suddenly we have less pixels. 1440 by 1080 only with this ratio. So we lose actually information. And you can set it up here in Premiere, for example. Once you go into the export settings, then you will have it, especially like below the resolution, you will see that there is a square pixel, and there is even more different kinds of aspect ratios. So always choose this one, nothing else. That's for us in processing. Actually, in general, for anything that you do, you should always use square pixels. Containers and codecs. A very big topic, actually. Containers and codecs. It's something very complicated. We get now into the file types and compressing. In general, when you export any video, I'm not talking about mobile phones or anything else, but if you export a video, especially a MOV file, it's uncompressed, then the video data becomes extremely large. For just maybe 1 minute, you might have like 10 megabytes or 20 megabytes perhaps, depending on the type of graphic. And a codec is a software or hardware, in that case a graphic card, that compresses this video data into a digital video. Yeah, so it makes it smaller, something that we can share, we can upload, and it's easier also to watch it online. So the codec is a software and a hardware. And additionally, there is the container. Containers are related to codecs. They actually, like the word says, they contain things. They're wrapping codecs and other information into one file. And there are a couple of them, you know already, such as QuickTime Format, or you have AVI or Windows Media Video Format, Flash Video, MP4 as well, for example. So containers are storing or wrapping elements of the video into one package, into one file. The common containers are MP4, MOV, ASV, AVI, for example, MKV as well. And the video codec is a software or hardware, like I said already, that compresses the videos. It's something similar that you used to from audio files. When you have MP3 files, they were actually compressed from a WAV file or maybe FLAC, FLAC files, to something that you can use on your phone, for example. So there is also some codecs in that sense. And additionally, in these containers, as we are used to from movies, there is like metadata, like author titles, dates, publication dates, licenses, maybe descriptions. There is also captioning, like subtitles. Maybe you have also more audio data inside, not just only one. There can be also various codecs within one. When you Google comparison of video container formats, you will find a lot of information on containers and codecs in that sense. You will see a lot of them. There is really a lot of different kind of containers for different purposes. They have different specifications, what you can actually do with them. Likewise, there are also coding formats that are put inside the container. There is like quite a lot of them, and each of them has different kind of strengths. So we can see here, for example, MPEG-4, which is H.264, the one most common encoding format. There is also HEVC, which is H.265, the successor of 264. Doesn't work on every player actually. I think Netflix is using this one. It compresses the files even more, and it also keeps the nice quality. And there is also, we have audio coding formats, like for example MP3, there is Lossy, Lossy. And as AAC is actually the better standard than MP3. So when you encode your videos, there will be always AAC that you can select, or it's already pre-selected for you. Let's have a look how that works actually, what the process is when we encode videos. So you might have a code in processing, and what you do, you usually create video data. Audio data, we skip it right now. You might also do audio data in processing, but generally we don't do this. So you generate video data. And to do that, you use these three methods like saveFrame, export video library, or screen capture. That's how we do it the first time. What comes next is usually the encoding phase or compression of your video data, because if it's uncompressed, you need to, of course, make it smaller. Otherwise, you might have like a 2 GB file. And for that, we use different kinds of codecs. This happens in another software, video editing software. It doesn't happen in processing unless you use the export library. There it is, there it will be encoded. The same happens for audio files. They become compressed. Once this is done, it is put into a container. The video data and also maybe the audio data, perhaps two different types of audio data. Maybe you have two different languages. I don't know, sometimes it's possible. Then there is also metadata, the author title and everything else, and then captioning. Not necessary for us when we work with processing, but the black part is for us important to understand. And once you have that, you usually use this container that becomes a file and open up in a video player. And the video player usually does the same thing. It separates it into a video codec and an audio codec. It starts the decoding again, and then it streams the information to your display or to your speakers. Knowing what kind of video players we have, we also understand what kind of requirements they are. Player is not just only on your computer, but actually also what kind of streaming platform you will use. For example, whether you use YouTube, Vimeo, or Facebook, Instagram, Twitter, they have all the kind of specifications for their own players. So we need to know them as well. So once you have this, we have to look into the requirements of the players, and then we also understand how we should export our videos, because those two things are related to each other. We cannot disregard the requirements when we export. Certain methods are more suitable for certain players. And the most important thing is the bitrate. The bitrate that we get from the requirements, so we know what is the maximum, and we also specify it in the video codec when we export. We get back to this in a bit. So for distribution and upload of videos, you should always use the MP4 container and an H.264 codec and an AAC for the audio codec. It's the most accepted video format usually. Basically, it works all over the place, and also those are the requirements for most of the video platforms that you where you could actually upload your information. So there is much more, of course, many more containers and many more codecs, but this is the most useful, or at least the most accepted. However, if you have like a high quality production, you will have definitely larger files. A larger file means you have more information. A smaller file means less quality, less information. Yeah. And for high quality productions, you will use rather like MOV container or AVI with a ProRes or DNHD codec. This is like to keep the quality of your animations or of your work intact, not to compress it. All right, bitrate. So I just mentioned bitrate. It is a very important topic. A bitrate is a number of bits, so a 0 and a 1, that are processed in a given amount of time. So for example, a bitrate of 30 megabits per second means that 30 million bits are being processed every single second in order to play a video and audio. And 30 megabits per second are equal to 3.75 megabyte. Doesn't sound a lot, but that's basically every single second, right? It doesn't sound a lot, but you have to imagine you have to play this on your, you have to basically transfer the information via internet to your computer. So 3.75 megabit is not that much actually. And a 120-minute video at 30 megabits per second equals to 26 gigabyte. This is very, very big. Yeah, 26 gigabyte, if you imagine. So high bit rates provide higher quality at the expense of the file size. 30 megabits sounds already quite a lot because it's 26 gigabyte. And we can compare this in this case, like for example, with DVDs, Blu-rays in Full HD and also UHD. A DVD has a maximum bitrate of 10 megabits per second. So you can kind of compare the quality. A Blu-ray with Full HD, so 1920 by 1080, has a maximum bitrate of 40 megabits per second. And a Blu-ray in UHD, Ultra HD, so 4 times the resolution, the amount of pixels, has a maximum bitrate of 128 megabits. That's an extremely large video file. You can imagine like the discrepancies. So the bitrate is fundamental. It's a fundamental number that tells us what quality we can expect of our video file. So low bit rates usually create a lot of problems. Like you can see in this image, you can see a lot of bending. Low bit rates create this bending, whereas high bit rates make a nice gradient. Likewise, low bit rates create macro blocking. I already said this in the videos that I was showing you before. That's what happens here. Because there is motion, there are lots of gradients, and the coding software is making this mess. The bit rates are too small. The same happened here in my videos before, you can saw this, and the same happened here as well. So now the reason for that was too low bit rate. It's not like I don't have the bit rate. I actually, on my computer, it looks amazing. The problem is actually the platform, YouTube, because they don't give me enough bit rate. And when we look at YouTube, they give us some encoding settings where we can look at them and we can check also what is the bit rate. So you can see the container is MP4 that they tell us to do. Also the audio AAC container, now we know where that comes from actually. Video codec is 264, very good. Progressive scan, no interlacing, okay, that's like basically very important, that's the P at the end. Variable bitrate, okay, there is something. No bitrate limit required, they say, but they do actually limit, cap the bitrate. Then the frame rates that they suggest is 24, 25, 30, 50, 60, and so on. So there is not like a strange frame rate. So always use basically those frame rates. And bitrate, the most important thing for us to know. So you can see already there is lots of specifications. It says like for standard frame rate of 24, 25, and 30, and the other one is for 48 to 60. And you can see already the bit rates vary quite significantly. Here we get only 8 megabits at 30 frames per second. So compare it to the Blu-ray, where we had about 40 megabits per second maximum. YouTube gives us only 8 megabits. So a Blu-ray has 5 times the quality, at least, what YouTube can give us. So you see already where you will have problems when you upload videos on the internet. And when you work with 60 frames per second, you get 12 megabits on YouTube, which is quite useful, right? So that's what I meant before. If you have high motion, something is moving, you definitely will need a very higher bit rate, because you also get you need to increase the frame rate to get the higher bit rate. You can use this actually. And it's about 50% increase from this here. So use always 60 frames per second so you can actually get a higher frame rate, higher bit rate. And there are two types of them. You can see here it's slightly bigger. It's 50 megabits per second at 60 frames, FPS. That has to do with the HDR or SDR. This is the high definition range, and this is standard definition range. That's about the luminosity, the colors, and the lights. We don't need to do this actually here, but you can also work with that. You can export. You can also select the settings in Adobe Premiere. When YouTube says something about variable bitrate, what is that? There are two types. We have the constant bitrate and the variable bitrate. You can see this in the graphic. So we have like the bandwidth, the internet, for example, and the constant bitrate is stable. It doesn't change. It doesn't matter whether you need it or not. Maybe your screen is just completely blank. It should be maybe just one bitrate would be enough. No, it just keeps it always the same way. So constant bitrate is good in terms of faster export times, but the files become larger, or also the quality maybe doesn't reach what you see on your screen. It can also cut it. Whereas the variable bitrate is slower, but overall better. Also, it can create smaller file sizes because it can go up and down. You can specify the range. When it's needed, when you have a lot of motion, it will have a spike. It will go up. When it's not needed, it will go down. Yeah? So it's kind of very useful actually to use the variable bitrate. And also the streaming platforms, they actually require as well variable bitrate because therefore they can also increase the bandwidth. And you can specify this here, like in Premiere, you can specify this in the export settings. You can see already there is a variable bitrate, 2 pass, and then you have a target bitrate, so like the minimum more or less, and then the maximum. I put it here at 40 megabits per second. It's quite a lot actually, yeah? That's very important for that case. 2 pass means that it will calculate it twice overly, and then basically trying to make it even better, the result. So that brings us to requirements for video export. How are the other platforms doing it, and what kind of standard we should set for ourselves when we want to export videos? And for that, to do that, we can just look at YouTube, Vimeo, because those are like the biggest streaming platforms that we can also use for us. And I think they also set the standard models. Then of course there is Twitter, Instagram, and Facebook. They're not that important, but we also look at that to understand why there is a quality drop in that sense. So YouTube, we already said it. Let's compare maybe 1080p, so full HD and 16:9 ratio. And we can see already YouTube had like at 30 frames per second, we had like 8 megabits, and 60 frames per second, we have 12 megabits. Whereas Vimeo, they actually suggest you from 24 to 60 frames per second, of course, and they give you up to 20 megabits per second. So that's almost like double. So there is a reason why actually you have to pay money for Vimeo if you want to upload high definition or high quality videos. And also there is a reason why many artists upload their videos there, because they actually can show the quality as well to their clients, for example. And Vimeo also uses different kinds of codecs. They also allow you to use 264 or Apple ProRes 422 or even H265, which is even better compression than 264. Smaller file sizes with higher bit rates. Whereas YouTube only asks for one codec. So those are two differences. So YouTube definitely has a much lower quality. Vimeo is better. Twitter and Instagram and Facebook is different, of course. Those are not streaming platforms, and I tell you, it's not very easy to find the information for those. Twitter definitely is very poor, so what I could find, basically maximum bitrate is, maximum frame rate is 30 per second, and the bitrate is like about 2 megabits per second. So it's really, really poor. Yeah? And the containers are also MP4, MOV, and H264. That's kind of the standard thing. Everyone has it. Instagram is slightly different. It offers us a 5 megabit per second at a variable bitrate. Yeah? 30 and 60 frames per second. So also quite low actually. But they have also 2 video codecs that they accept in that sense, which is also okay. And then Facebook is different. It's not easy to find information because they actually give us this 9 megabits per second as an option but that's only for the business part, I guess. When you pay money to them, then they open up a higher bitrate for you. Otherwise, I don't know how much it is because it's not very clear. They're not very transparent in that sense. But again, you understand why the quality on these platforms is quite low when you watch them, if you upload it, if you upload your work on that. So, to summarize that, for motion, always aim for a high bitrate and frame rate. Always. The higher the better, because you get like a 12 megabit per second bitrate at a 60 FPS on YouTube, for example. That's quite good. And export always with a variable bitrate, VBR, 12 to 40 megabits per second. When you use a video editing software, you can set it up there. 40 is quite high, but you might have very high peaks, so the encoder on YouTube, for example, they will see this and they will also calculate it down a little bit if they need to. But it's good to have it. And use higher bitrates to lossy formats. So that's another thing that I will talk about now. Lossy versus lossless. Lossy means that there is a compression, and during the compression the data is permanently removed. So for example, like in JPEGs, you save a JPEG, you close the file, you open up again, you save it again, you close it again, save it again. So what happens is every single time you save the file, you lose information. And that's what happens with certain video containers or video codecs as well, that you lose actual data, especially during the post-editing phase, when you want to reuse certain footages and you put them nicely in your editing software, you edit them, you export again, still looks kind of okay, it's already less quality, then you upload it on YouTube, and then suddenly the quality completely drops. Yeah? The lossy format, however, allows us for smaller file sizes, and it's usually like MP4 containers. Lossless, on the other hand, is also compressed, but the quality is the same. The files are larger, but if you look at that, usually when you re-edit the file, you work with that, the quality stays the same. It doesn't matter how many times you save it or re-edit it. And usually the container for that is an MOV container, and you use like ProRes or Avid DNX codecs for that. It's likewise for PNG, for images is the same thing as well. Yeah. So lossless is a big thing. And then of course the last one is uncompressed. This is the highest quality, very large files, and you can use like MOV containers or AVI files. That's equal to TIFF files for images or PNG files, likewise also WAV for audio. So you have like basically these three options. The first one you should never really work with, otherwise you lose quality. And you can see this significantly if you work with graphics like lines. You will see the huge difference. And what happens here in that case, in this graphic? So let's compare this lossy versus lossless. SaveFrame, of course, is the best one, I said already in the beginning, because it is a lossy, lossless or uncompressed format. And there is nothing encoded. So what we do here, in processing, we instantly create an MOV container with all the data, uncompressed data. And this is actually quite good for post-production. The files are bigger. You cannot open them in not every player can open the file, but you can work with it. And so, like I said already, you have to basically post-edit it. It's necessary, but it's good. If you know it, you use this type of export, so you can also actually work with it. And I usually work with that type, with this method. So use SaveFrame with MOV container is usually the best for export of uncompressed video files. Likewise, when you do that, actually remember, use PNG for that when you export, not JPEG. JPEG is already compressed, so PNG is uncompressed again. Yeah, or if it is compressed, it still keeps the format because it's lossless. So keep in mind, PNG, not JPEG for SaveFrame. For the other ones, like export video library or screen capture, that's usually this kind of softwares or this library and the screen captures, they always, in general, they export at 264, H264 codec and MP4 container. This is generally a lossy format. So if you use these methods, what happens is you have a very poor quality because you might want to re-edit it, the graphic, and then you lose even less, you will have even less quality in your video. So Export library and screen capture are very fast but lossy, so usually it is 264 and MP4, where the video image quality decreases. That's what happens when you use those two options. Next thing is that relates to lossless and lossy. You will find those. You will basically encounter those terms like intraframe and interframe. Intraframe codecs are lossless and interframe codecs are lossy. So when you do post-production or you do professional, you work actually with videos, you would rather work with intraframe codecs in the beginning, because intraframe codecs scan and copy one frame at a time, whereas the lossy codec, it compresses with frame blending. That means that the codec is checking all frames next to each other, and if they kind of are similar or the same, it basically blends them together. It basically meshes them together. And if there are too small differences, it removes the details from that. And those details will never again reappear because the frames are gone. Whereas the intraframe, it will keep every single frame. So they have higher quality intraframe codecs, and they are lossless. We usually use those for editing, not client delivery, unless your client wants to have it. And the interframe codecs, lossy, they are good for delivery and uploading, like on YouTube, for example. The popular intraframe formats, if you work with like Premiere in that case, you will find out like you have ProRes, or especially on Apple, because it's an Apple codec. Then you have DN and HR. You can use those to actually work with them. Perhaps in case you want to reuse the footage at a later stage in a different kind of project, so you should always save it that way. Whereas when you upload it, or maybe you finished your video, you can always use this kind of codecs, 264 or 265. I think 264 is the best one. All right, my recommendations. For editing, use the container MOV. That's basically that you get directly from processing. Use or AVI if you want, if you maybe save it afterwards. Use uncompressed files, or use a codec, a lossy codec, a lossless codec. So for example, ProRes or DN HR. But I think this is not very necessary for us when you work with a code, because you don't need to keep the files. Otherwise you have like gigabytes, many gigabytes of files on your hard disk, and storage is money actually. And usually you might have it, or I usually have some of them as well, but I hardly use them actually. So the better way is you can always save your sketch, your processing code. And if you need to have an uncompressed video file again, you can just run it and export it again. So you just don't touch again the the processing sketch. For delivery and upload, like delivery to a client, for example, you want to communicate, use rather MP4, because everyone can basically open it up. And the codec is generally 264 with a high bitrate VBR. That's always the best way. For working with processing, choose the resolution FHD 1920 by 1080, 60 frames per second for motion, or 30 frames per second for regular or slow animations, that is drawings especially. And then when you export things, choose a very high bitrate, 12 to 40 megabits per second at a variable bitrate, and this would be for 60 frames per second. And I would also do the same for 30 frames per second, because if you upload it somewhere, so basically the encoders from YouTube or other platforms, they will usually they need more information to work with. It's better. Very important when you write your sketches for videos, pay attention to line thicknesses, avoid gradients, like remember the banding and macro blocking on my videos, or the cases, the examples. And always another aspect actually quite important, which I always forget, or at least I have to remind myself, high contrast colors are better for animations. You can see this here on those two animations, left and right. Right side is an uncompressed video, left side is already a compressed video, MP4 H264. And what happens is, I think YouTube has already compressed these images, so you will not see much difference. But you can see here already, in that case, it's kind of meshed and blurred. It's not because that the color is not clear. No, it's actually the edges. the edges are the problem, because the blue and the red are too close to each other, so the codec 264 will need a much higher bit rate to actually process that. On the other hand, it's uncompressed, so it should be here quite sharp. The video that you watch on YouTube is of course already compressed. So, but anyway, you should see the big difference in that case. So keep in mind, if you work with certain colors, particularly like red and blue, you will have problems at a certain stage. Okay, I think that's it basically. If you have any questions, suggestions, or perhaps you'd like to share your own experiences, and maybe you have some better ideas how to export videos, maybe you want to share your knowledge, please write it down in the comments, because it is actually a big topic, and I think people in general who work with videos, they always have problems. There will be always some issues, and the more people share their knowledge or their experience, the better for us. Otherwise, I see you in the next video where I will talk about the 3 methods, export methods, where I also will emphasize on each strengths and weaknesses. So see you in the next video. Thanks for watching.